Hello everyone, wishing you all a very good afternoon. Am I audible and visible to all? Vishnu? Great to see you guys back. Well, today is the class for the fourth lecture on electro. We will proceed and try to wind up in this lecture, maybe in one more lecture. Then we'll move on to capacitance, electric current, and a lot of other things. I hope I'm audible and visible to everyone, right? Let everyone join. Meanwhile, just to tell you, as I told you, one of my students whose name is Abhinav, he got All India rank 3 in ISI. He actually had this JEE mains on 31st and he has checked his answer key and he is expecting around 243 marks out of 300. So that will land him up somewhere, I think, in 99.5 or somewhere of that range, in that percentile range. He told me yesterday. Now, why I wanted to bring this child into the picture, I'll tell you how many questions he tried and how many questions of his were right and how many of his questions were wrong. He tried 22 in physics, 19 in chemistry. Chemistry is his weaker topic. 20 in maths. These are his trials. And according to him, official key, all of these questions are right. He's only confused with one question in maths, which he thinks is wrong. And I think that gets him 243, 244 in positive marks, and I think 1 in negative marks. What I wanted to tell you here is, if you follow certain principles correctly, that you only attempt question that you know, and you only attempt question that you are confident about, you could get a good score. 243 should get him somewhere around 99.5, somewhere in that range. That is my guess. Well, I hope that he gives JEE Advance and probably his rank in JEE Advance would be under 100 somewhere because he is too good. Not for means, but he is too good in advance. As you can see, his rank in ISI Maths is 3. So he must be doing good in maths, and JEE Advance will test him more nicely. So what I tell you is, if you can apply what you are reading in the class, apply it correctly, make your stronger points very strong, you should be able to score heavily in the exams. Okay, most of the questions that you will encounter in the exams, you will imagine, you will understand that you have already solved those questions in one form or other in the class. So you have to be attentive in the class. Having said that, let us move around and think about what we were discussing in the previous class. I think in the previous class we were discussing about what? About electrostatic potential and electrostatic potential difference. Is yes or no? Can you just tell me by raise hand that we were discussing that electrostatic potential and electrostatic potential difference, and I told you that electrostatic potential difference is defined. The absolute value of electrostatic potential is not defined, because to define electrostatic potential absolute value or electrostatic potential energy, we need to find a point whose potential can be taken as infinity. In most of the cases, that point can be taken as a point at infinity, but in some cases, that infinity point does not have zero potential, and the cases being an infinite line charge or line mass, or infinite sheet. These are the examples where you cannot take the potential of infinity as 0, and therefore you cannot find the absolute potential. You can only find the potential difference by integrating E with dr. Do we remember this? Can I have some reason that we understand this, sir, so that I can move forward? Am I audible, visible, everyone? Can you understand me? Vishnu, Jyoti? Okay, fine. Now, going on to the formula for electrostatic potential, due to a point charge. Here also the potential at infinity I have assumed at 0, and then the potential at any point at a distance r becomes kq by r. Remember, difference between electrostatic potential and gravitational potential. Electrostatic potential is positive for positive charges and negative for negative charges. But gravitational potential will always be negative. It is never taken as positive. Now, the formula for gravitational potential is, instead of K, you put G. So, gravitational potential due to a point charge, you can call it by the letter V. G, gravitational potential, it will be minus Gm by R, where R is the distance of the object from the mass from the point. And this is how the graph looks like. At infinity it is 0, at very close point it is very high. This is the graph of electrostatic potential. It is treated as positive. If it would have been the graph for gravitational potential, the graph would have looked like this. Do we understand this? Can I move forward? Then we have gravitational potential or electrostatic potential for a ring. Same formula at the center at any point on the axis. This is the formula. You can also find the formula for gravitational potential. Just replace K by G, Q by M, and put a negative sign. This is how the graph looks like. Remember, gravitational electrostatic potential is highest for a positive charge at the center of the ring. Do we understand this? Yes or no? That takes us to a uniformly charged, hollow, conducting or non-conducting sphere. Uniformly charged, hollow, conducting or non-conducting or solid conducting sphere. The charge will be on the surface. Electrostatic potential at any point at a distance r. Outside will be Gm by r, I mean kq by r. Inside it will be same as potential on the surface of the conductor. Remember, a conductor is an equipotential surface. The potential of all points on the conductor are same, and the potential of any point inside a conducting sphere will be same as potential on the surface of the sphere. And this is how the diagram looks like. Am I clear? This diagram is also valid for a hollow shell. If you want to find the gravitational potential, the only thing, it will be minus Gm by r. Then you have uniformly charged non-conducting sphere. The formula at a distance r outside is same. On the surface, the formula will be kq by r, but inside at any point, these are the formulas which you must remember. These are the points that at the center, the electrostatic potential is 3 by 2 times the surface. You must remember this. Same formula is valid for gravitational potential due to Earth, which is a uniform sphere. On the center of Earth, it will be minus 3 by 2 Gm by R. On the surface of Earth, it will be minus Gm by R. Do you all understand this? Can I have some raise hand that we understand this, sir? Infinite line charge. The gravitational potential is not defined. You can only find out the gravitational potential difference between 2 points by integrating the gravitational or electrostatic field. For a non-conducting sphere, for the sphere beta, this is the formula. You must remember this formula. I've already sent you the sheet. 3kq, I mean kq by 2r cube multiplied by 3r square minus 2r square. To find out the gravitational potential at the center, put the value of r as 0, it will become 3 by 2. So the gravitational potential at the center is 3 by 2 times the potential on the surface. Clear? I mean, I'm saying gravitational potential at times, I'm saying electrostatic potential at times. You must understand that both mean the same thing. We are doing gravitation as well as electrostatics together. Clear, beta? Okay. Then we have infinite line charge and infinite non-conducting sheet. We do not have any formula for absolute value of gravitational potential or electrostatic potential, because there is no point whose potential can be taken as infinity, and therefore we can only find out the difference in gravitational potential. You must remember, conducting and non-conducting sphere, why it is different. For conducting sphere, all the charge still remains on the outer surface. For a non-conducting sphere, charge comes inside the sphere as well. That is why the formulas are different. Am I clear? For a non-conducting sphere, the charge will go inside the sphere. For a conducting sphere, the charge will remain on the outer surface of the sphere. Am I clear? Now remember, gravitational potential or electrostatic potential is a scalar quantity. So if you are supposed to find out gravitational potential or electrostatic potential due to variety of different charges, how will you do it? You will just find gravitational potential due to one body, find the gravitational potential due to the next body, and simply add them. As in this case, we are supposed to find the gravitational potential at point C and point D. Point C is here, point D is here. You find the gravitational potential due to A. If it is positive charge, it will be positive. You find the gravitational potential due to point charge B. If it is negative, it will be negative. Gravitational potential is a scalar quantity. You don't have to look for direction. You can simply add them just like numbers. Do we understand this? Do we understand this question? How we have done this question? Yes or no? Yes or no? Great. Simple questions and a simple answer. Now, well, a formula that we have seen is only valid for a point charge kq by r, or for a conducting or non-conducting sphere. If you have continuous mass, how will you find out? A rod of length L and mass, it could be length L, mass M, or length M, length L and charge Q. Calculate the potential at this point. You have to break this rod into smaller point charges and find the gravitational potential due to one point charge, and then add up all this. You are not going to do this thing in the examination hall. So what are you going to do is remember this formula, kq by l. Q by l sometimes is also known as lambda, which is charge per unit length, or you can also call it mass per unit length. Replace this by g, q by m, length by l, put a negative sign, and this formula multiplied by log to the base e becomes the formula for gravitational potential due to a line charge. Do we understand this? You have to remember these formulae, because the question that comes in the exam will not be asking you to find out the gravitational potential due to this, but they will be asking you something else. They might put a charge there and they might make the charge to move. They will ask you with what velocity it passes the rod, or with what velocity it hits the rod. Then you have to find the gravitational potential energy or electrostatic potential energy in first case, electrostatic potential energy in the second case, and equate it to the total energy. Total energy will remain constant, and hence you can find out the speed. Do you understand what I'm saying? So not, you will not get a straight question. The question will always be asked in a roundabout way. You must remember that gravitational potential of a ring, we have already calculated it, kq by r, due to a non-uniformly charged ring. If it is non-uniformly charged ring, here some charges are here, here there are less charges, there are no charges here, still the answer is kq by r, because it is a scalar quantity. Does not depend on the distribution. It only depends on the charge and the distance. Do we understand this? Can I have some raised hand that we understand this? If it is even a half a ring, total charge is q, the answer is still k q by r. Do we understand this, what we have written it here? Due to half ring, any portion of the ring or any Non-uniform charge distribution also, the gravitational potential remains same. Gravitational potential on the axis of the ring, we have already calculated its formula, we have already seen its graph. You must be able to remember it. Now, this is a question that can be asked many times. There are two charges, two rings having charge plus q and minus 5 minus root 5q. What is the potential difference between point A and point B? This is one variation of the question. In the second variation of the question, what they can do is they can place a positive charge plus small q at the center of this ring. What will happen to this charge? This will move along this line AB. With what velocity it passes the center of the other ring? They can ask you this question. How are you going to do this question? You are going to do this question by law of conservation of energy. Total energy at point A should be equal to total energy at point B. What is the total energy at point A? Potential at point A multiplied by Q. The velocity is 0. What is the total energy at point B? The total potential at point B multiplied by small q. That is the potential energy, gravitational potential energy or electrostatic potential energy, depending on what question is based, plus half mv square. So total energy at point A will be total energy at point B, which is on point A, it is only electrostatic potential energy. At point B, it also will be gravitational potential, electrostatic potential energy as well as kinetic energy. From here, you can calculate the velocity. Now this UA minus UB can also be written as UA minus UB will be equal to half mv square. This UA minus UB can be written as Q multiplied by VA minus VB. So find the potential difference between the 2 points, multiplied by the charge, equal it to half mv square, and from there you can calculate the velocity with which it passes through the center of the ring, second ring. That is everyone getting what I'm saying? Can I have raised hand that you have understood what I have said? How you can create a question out of this? So you have to find the potential difference between point A and point B. Potential at point A. Who is going to create potential at point A? This is the positive charge. The point A is at the center of this charge. This is the potential due to charge B, ring B. At point B, this is the potential at the center of ring B due to ring B. This is the potential at the center of B due to the other ring. This is VA, this is VB. You can easily find out VA minus VB from this concept. Do we understand this? Can I have raised hands? That we understand how we have calculated VA minus VB, yes or no? Great. Now see, as I was talking about the question where they asked you the kinetic energy, this is the question. A point charge Q naught is placed at the center of a uniformly charged ring or total charge Q and radius R. If the point charge is slightly displaced with negligible force along the axis of the ring, then find out the speed when it reaches a large distance. So basically, when it reaches a large distance, its total energy will be kinetic energy because potential energy will be 0. So energy at the center of the ring will be equal to total energy. Total mechanical energy at the center of the ring will be equal to total mechanical energy at infinity. Total mechanical energy at the center of the ring will be potential energy plus kinetic energy. Kinetic energy 0, and total mechanical energy at infinity will be potential energy at infinity, which is 0 plus half mv square. From here, you can find out the velocity at infinity. The same question could be asked in the form of escape velocity from Earth. This is the planet Earth. This is a planet Earth. With how much velocity I must throw this that it never comes back. Total energy at Earth is potential energy of Earth and this mass plus the kinetic energy of this mass. At infinity, the total energy becomes 0, kinetic energy becomes 0, potential energy becomes 0. From here, you can calculate the escape velocity from Earth, root over 2 gm by r. Do we remember this? Same question. Here it is ring. There it was a sphere. Same question. Same question I think will come. Do we understand this? That is how you create or find out the escape velocity from Earth, or sometimes it may be asked what is the escape velocity from the center of Earth. From the center of Earth, how will you find the escape velocity? You find the total energy at the center of Earth. Total energy at the center of the Earth will be gravitational potential energy. That will be gravitational potential minus 3 by 2 gm by r multiplied by mass m, small m, plus half mv square. That v will be the escape velocity from the center of Earth. At infinity, total kinetic energy becomes zero. Total potential energy becomes zero. From this concept, you can also find out the escape velocity from the center of Earth. Do we all realize this? Do we all understand this? Can I have raised hand that we understand this, sir? Do we understand this? Can I have some raised hand that we understand this, sir? No one understands this? Okay, great. Now we have gravitational potential due to a uniformly charged disk. You might not find this formula elsewhere, so please remember this formula. It is sigma by 2 epsilon naught root over, I will just write it, I think it is misprint, sigma by 2 epsilon naught in the bracket root over r square plus x square minus x, where x is the distance from the center of the disk. Here, here it is calculated by using the technique of integration. And as you can see, this is the formula that you get. Now, the same question can be asked in a different way where you have a hole in the disk. How will you do it? Again, you will assume that there is no hole in the disk. To find out the gravitational potential due to the entire disk, then to create the hole, you put a negative charge in the hole, you find the gravitational potential due to that negative charge. Add these two, one will be positive, other will be negative. You will get the gravitational potential due to a disk with a hole. And this is the graph that you are looking at. Please remember this graph. At x is equal to 0, which is the center of the disk, you will have the maximum value of gravitational potential. I'm saying gravitational potential, that's to be electrostatic potential, sigma r by 2 epsilon naught. Do we understand this? You have just put the value of x where you have just put the value of x as 0. Do we understand this? Uniformly charged spherical shell, we already know the formula. This is a derivation. We don't need to get into the derivation. We already know this formula. Solid sphere also, we know the formula. At the center of the sphere, it is minus 3 by 2. This is the question that we are looking at, where we are going to apply whatever we have learned. Example number 58. Two concentric spherical shell, radius r1 and r2. R1 is smaller, r2 is bigger, are having charge q1 and q2. Find the potential at point A on the surface of the smaller disk, on the surface of the larger disk, at r greater, smaller than or equal to r1, at r between r1 and r2. So basically, at all the points inside the smaller sphere, on the surface of smaller sphere, between smaller and larger sphere, on the surface of larger sphere, and outside the larger sphere. How will you do this? Any question of this type? Break this shell, break this shell into two different shells. One is the inner shell, one is the outer shell. Find the potential due to inner shell, find the potential due to outer shell, add and subtract depending on whether they are positive or negative, and you will get the formula. For example, potential at point A, which is the center of the inner shell, potential due to the inner shell is this one, potential due to the outer shell is this one. Remember, inside a shell, potential is same as on the surface of the shell. Point B, which is on the surface of the smaller shell, potential due to smaller shell is like this, potential due to larger shell is like this. At point C, which is on the surface of the larger shell, this point is now outside the smaller shell, so the formula changes for smaller shell, but the formula remains same for the larger shell. For any point inside the smaller shell, it will be inside for all the shells, inside and outside. So therefore the formula remains same. So this is what you must understand and remember. Have you understood this, or have I gone too fast and you are not able to understand it? See, if I go very slowly, the problem will be to I will not be able to complete this course because time is very less. Okay, I think this is done. So you can do question of this type easily. You can do question of this type easily. Now let us move on to some questions where you might have to find the potential difference between 2 points. In some cases, it is going to be a uniform electric field, potential difference between point A and B. How do you find it? Remember, potential difference is negative of E dot dr, negative of E dot dr. You can always integrate E with dr and find out the potential difference. If it is a uniform field and you have to find out the potential difference between A and B, choose path in such a way. You go like this, then you go like this. If you move in a direction which is perpendicular to the direction of electric field, potential does not change. Such points are known as equipotential points. Do we know this? So if you want to find the potential difference between A and B, you don't have to go from A to B in this path. You can go straight along the electric field, potential will decrease. Then you go perpendicular, potential will remain same. So potential difference between A and B will be same as potential difference between A and C. It is easier to calculate potential difference between A and C. It will be E multiplied by D. A will be at higher potential, C will be at lower potential, because electric field lines are always going from a point of higher potential to a point of lower potential. In the direction of electric field, potential always decreases. Am I clear with this concept? Am I clear with this concept? Anyone has any doubts on this, please raise it, because you may find a question of electric potential or gravitational potential and you should be able to solve it. For example, this question, example number 62. Find out the gravitational potential or electrostatic potential between A and B, B and C, C and A, D and C, A and D. Arrange the order of potential A, B, C, D. You can tell me which will be at a higher potential. Looking at the diagram, electric field lines are going like this. Which will be at the higher potential? Which point will be at the highest potential? Which point will be at the highest potential? Anyone giving answers? Point A will be at the highest potential and point D will be at the lowest potential. Yes or no? We understand this? Potential of point C and D will be same, because from C to D, when you are moving perpendicular to the direction of electric field, and perpendicular to the direction of electric field, potential does not change. So potential difference between A and B will be 20 Newton per coulomb electric field multiplied by 2 centimeter. 2 centimeter is 2 into 10 to the power minus 2 meters. So multiply electric field by the distance along the electric field and you will get the difference in potential. A is higher, B is lower, and hence the answer is this. I hope you can find out the rest of the answers. Can you find out the rest of the answer? I'll give you a minute to find it out. I hope you can find out the potential distance between B and C, C and D, and so on. The question is pretty straightforward. You should be able to solve this. Yes or no? Can I have raised hand that you have solved this? Have you solved this question? Okay, I hope you have solved this question. Now, if someone asks you, if someone gives you a question to find the electric potential due to an infinitely long wire, then you have to use this formula of integration. You have to integrate it from A to B. You have to find out the electric field 2 times k lambda by r and integrate this. This will be the potential difference between the 2 points minus 2k lambda natural log of LRB divided by RA. Remember, electric field always goes from a higher potential to lower potential. So potential of point A will be higher if it is positive charge. If it is a negative charge, potential of point B will be higher. Do we understand this? Yes or no? Please raise your hands. Similarly, for an infinite, long, thin sheet, potential of point A will be higher, B will be lower. If this is positively charged, sigma. If it is negative sigma, potential of B will be higher, potential of A will be lower. And you can always find it by sigma by 2 epsilon naught, which is the electric field, multiplied by the distance d. Am I clear with everyone? Remember these small things, and these small things are going to make a large difference in your final assessment. If you can raise your hands, I would move forward. Have you understood this, beta? Sai Teja, Vishnu, Chetan, Sudha, are you all there in the class, beta? I don't have so much time that I can wait, so I'll have to move with the next definition, and the next definition is definitely the definition of an equipotential surface. Please listen to me very carefully here. Equipotential surface, if you move in a direction which is perpendicular to the electric field, all the points will have same potential. That surface, if you create a surface on which all the points have same potential, it is known as equipotential surface. If you shift a charge from one point to other, or a mass from one point to other, there is no work done. Electric field is always perpendicular to an equipotential surface, and two equipotential surface never cross each other. We know these properties, yes or no? I hope you know these properties. I'll have to move forward. What type of equipotential surface you will find? So if it is a point charge, the equipotential surface will be spherical in shape. Now these equipotential surfaces are same as your wavefront. Do you remember wavefront? Wavefront is the locus of all points. Wavefront is the locus what? Say E0 value, sir. I don't know what is the meaning of E0. Uh, wavefront is the locus of point. Wavefront is the locus of all points which are in the same phase. So I don't understand what you're saying. So for a point charge, the equipotential surface will be spherical in nature. If it is a spherical charge, also the equipotential surface will be spherical in nature. If you have a light source, which is a point light source, the wavefront it will create will be spherical. Remember that. If you have a charge or a mass which is a line charge or a line mass or a line source of electricity, light, it will create cylindrical potential, equipotential surface, or a line source of light will create cylindrical wavefronts. Uniformly charged, non-conducting or conducting sheets. If you have an infinite sheet of charge or mass, it will create plane equipotential surface like this. So these are the things that you must remember about equipotential surface. Equipotential surfaces are same as wavefront. So you can, if you understand equipotential surface, you must be able to understand wavefronts. That takes us to this question, example number 63. Some equipotential surface are shown in the figure. what you can say about the magnitude and direction of electric field. Now remember, electric field line is always perpendicular to a equipotential surface. So electric field lines will go like this. Will it go like this in the blue manner, or will it go like this in the red manner? So these are the two possible directions of electric field. How can we understand whether it will go along blue line or along red line? If you read the value of potentials, you should be able to tell me whether it will be blue line or the red line. Which would be the line of electric field, red one or the blue one? They have to be perpendicular to the equipotential surface, yes. But what about red or blue? Red is also perpendicular, blue is also perpendicular. Which is the electric field line in this case, red or blue? And what is the reason? Anyone can get me answer? What will be the direction of electric field? Whether it will be red line or the blue line? It will be the red line. Why it will be the red line? Because red line are going from higher potential towards lower potential. Do we understand this? Red lines are going from higher potential to lower potential, and hence red would be the electric field lines. How will you find out the value of this electric field? How will you find out the value of this electric field? You just have to divide. You just have to divide these lines, the difference between the potentials, by the perpendicular distance between the potential lines. If you can find out the perpendicular distance, you will be able to find out the value of electric field. Potential difference divided by the perpendicular distance. Potential difference is 60 volt divided by the perpendicular distance. It is 10 sine 37. Am I clear? Do we understand this? Can I have reason that we understand this? And which direction it is going? Is it going in direction number 2, which is like this, or is it going in direction number 1, which is like this? Which direction it is going? It's definitely going along direction 2, because electric field lines always move from a point of where to where? Electric field lines always move from a point of where to where?
Higher potential to lower potential, sir.
Higher potential to lower potential. That is absolutely correct, and that is how you get the answer for the direction. Then you have electrostatic or gravitational potential energy. You multiply the charge with the potential, or charge with the potential difference, or mass with the potential difference. You get the value of potential energy or change in potential energy. Now, these type of question will always be about what is the potential energy of the system. For example, this example number 65, what is the potential energy of this system? How will you calculate the potential energy of this system or any system of these charges? You have to divide the charges into pairs. How many pairs you have? You have one pair like this, one pair like this, one pair like this, one pair like this, four pairs of Q and Q at a distance of A. Then you have one pair of this charge and this charge, one pair of this charge and this charge. Basically, you have 4C2 number of pairs, six pairs. You have to find the potential energy of one pair, second pair, third pair, fourth pair, fifth pair, sixth pair. This is one pair, first pair, second pair, third pair, fourth pair. They have not found out. I don't know why, something wrong. Then you have to find out the energy of all the pairs, add them, and find out the total energy of the system in this way. So the energy of any system can be found out by finding out the number of pairs. Do we understand this? Do we understand this? Yes or no? Now, based on this 2-point charges की energy, we can make a question like this. 2-point charges, each of mass m and charge q, are released when they are at a distance r from each other. What is the speed of each charge particle when they are at a distance of 2r? So how will you find out the speed of these charge particles when they are at a distance of 2r? So the first thing is that you apply law of conservation of momentum. If the velocity of this charge is v, the velocity of this charge will also be v, because the initial momentum of the system was 0. Final momentum of the system will also remain 0. Both the masses are same, so both the velocities would be same. First you apply law of conservation of momentum, then you apply the law of conservation of energy. In first case, this is your case number 1. Total kinetic energy of first is 0. Kinetic energy of second is 0. The total energy that they have is potential energy. Then they have kinetic energy half mv square for first one, half mv square for second one. Total kinetic energy becomes 2 times of half mv square. Total potential energy becomes kq square by 2r. The distance becomes 2r. From here, you can find out the velocity of the charges when they are at a distance of 2r from each other. Do we understand this? Can I have some reason that we understand this, sir? That takes us to example number 73. 4 identical point charges are placed at 4 corners of a square. Find the potential energy of this system. How will you find the potential energy of this system? 1 pair, 2 pair, second pair, third pair, fourth pair, fifth pair, sixth pair. Find the energy of first pair, second pair, third pair, fourth pair, fifth pair, sixth pair. Add them together and you get the energy of the entire system. Now, if they are point charges, they only have mutual energies. The energy that we have calculated is known as mutual energy because it comes from 2-point charges. Now, instead of point charge, if you have a continuous charge, for example, a shell or a sphere, is a collection, or a rod is a collection of large number of point charges. It becomes one body. The shell becomes one body. This one body has its self energy. If it is electrostatic, it will have electrostatic self energy. If it is gravitation, it will have gravitational self energy. How did you calculate it? You don't need to see this. You must know what is the self energy of a shell. The self energy, the electrostatic self energy of a shell or a conducting sphere is kq square by 2r. If you have to find the gravitational energy, it will be minus gm square by 2r. Remember, gravitational energy is always negative. But self energy, whether it is electrostatic, whether it is positive charge or negative charge, self energy is always positive. For electrostatics, for gravitational, self energy is always negative. For electrostatic, mutual energy between two charges, if both are positive, it is positive. If both are negative, it is positive. If one is positive, other is negative, it is negative. But gravitational energy, whether it is mutual or it is self, it will be always negative. For a shell, it is kq square by 2r. For a sphere, non-conducting sphere, it is 3 by 5 kq square by r. For earth, the gravitational self-energy is minus 3 by 5 g m square by r. Will you remember this? Can I have some raise hand that will remember this, sir? What have I said? Will you remember this, beta? I'll again repeat, gravitational energy, whether it is self or mutual, it is always negative. Electrostatic self-energy is always positive. Electrostatic mutual energy will be negative if one is positive and the other is negative. That is what you must remember. This is a small question based on the concept that should be able to clear it. Two non-conducting hollow uniformly charged sphere. So it is hollow sphere. So it is q square by 2r, kq square by 2r. Both are positive. These are the self energies and this one is the mutual energy. Do we understand this? Can I have raised hand that we understand this, sir? You have to find the total energy of this system. This term consists of the self energy of the two bodies, and this term consists of the mutual energy of the two bodies. Am I clear? Can I have some raise hand that we understand this, sir? Do we understand this? Okay. Then sometimes you might come across this term of energy density. Energy density is energy per unit volume. In a unit volume, how much energy is stored? That is always equal to half epsilon naught E square. If you talk about magnetic energy density, it will be B square by 2 mu naught. I'm telling you, if it is magnetic energy, it is B square by 2 mu naught. If it is electrostatic energy density, it will be half epsilon naught E square. Will you remember this? You remember this concept? Please raise your hands and tell me, sir, you will remember this. All these small points can come to you in exam in any form. Then you will probably understand how important this class was when you attended it. Jyoti, Chetna, Saiteja, Vishnu, do you understand this, beta? Okay. Now this is a small question based on this concept. Please solve it. Find out the energy stored in an imaginary cubical volume of side A in front of a infinitely large non-conducting sheet of uniform charge density sigma. That is the question that you are supposed to do. That is the question that you are supposed to do. How will you do this? How will you do this? It's very simple. So I can write this like this: du by dv is energy per unit volume. That will be equal to half epsilon naught E square. Du small energy will be half epsilon naught E square into dv. Total energy will be sum over this. Sum means integration. Just integrate this. Half epsilon naught E square is constant here. So integral of dv is simply v. You just put the value of volume v. You just substitute the value of electric field as sigma by 2 epsilon naught. So half epsilon naught E square becomes half epsilon naught into sigma square divided by 4 times epsilon naught square. You put the values and you get the answer as sigma square a cube by 8 epsilon naught. Do we understand this? Can I have raised hand that we understand this? That takes us to the last topic of today's class, relation between electric field and electric potential. I have already told you relation between electric field and electric potential. To find out electric field from electric potential, you have to do this minus del V by del X I. That will be the electric field ka component along x-axis minus del V by del Y of J minus del V by del Z of K. This is also known as minus grad V. This is the term taken from gradient term taken from mathematics. You must know the value of del V by del X. Del V by del X is the partial derivative of v with respect to x. Del v by del y is the partial derivative of v with respect to y. Del v by del z is the partial derivative of v with respect to x. This is how you find out electric field from potential. To find out potential from electric field, we already know the formula. Vb minus va is minus E dot dr integral taken from a to b. And now we'll solve a question based on this. And this is right here, example number 82 and 83 is what you will do as homework. You can do example number 82 here. X square plus y is v. To find the value of E, where E is the electric field. Okay, so how do you do this? Del v by del x, partial derivative of v with respect to x is 2x. Del v by del y is partial derivative of v with respect to y, that is 1. Del v by del z, there is no z component, so it is 0. So you put the value and you get it minus 2xi plus j hat. Electric field is non-uniform, as you can see. The next question is finding out the value of potential difference from electric field. So you just have to do it. Ex dx, I already told you dv will be equal to integral of dv will be equal to integral of ex dx plus ey dy plus ez dz. Remember, it is same as what we calculated work done from a conservative force. Remember, work done is integral of fx dx plus fy dy plus fz. Do we remember this? Delta work divided by mass m will give you potential difference. So this becomes divided by m, this becomes divided by m, this becomes divided by m. This becomes electric field or magnetic field. We divide it by m, it becomes it becomes gravitational field. We divide it by mass, gravitational field. Divided by charge, electrostatic field. That is how you can find out the value of potential difference or work done from electric field, gravitational field, or electric force and gravitational force. In tomorrow's class, what we are going to do, I will ask you to read this chapter on dipole. I will not be doing this dipole part. All the formulas are given here, so you can go through these formulae of gravitational potential and electrostatic potential due to a dipole. That is what you got to do. Electric field at any general point, you can do this on your own. You can remember these formulas on your own. So electric dipole you will have to do on your own. Electric field due to a small dipole at equatorial point, axial points, equatorial points. You have to remember all these formulae. So this part I will skip. Dipole in an electric field, dipole in a magnetic field, it experiences torque. I hope you know this. I would start from here, dipole in a uniform field. I will not be doing the derivation part of what is a dipole and what all. So I'll probably start from here and we will try to wind up this chapter. What is left is electric flux. So we'll try to complete electric flux in the next class and wind up this chapter in the next class, at least electrostatic, so that we can move on to the next topic, which is capacitance. I will end today's class here on this note. Electric dipole, the important definitions, you have to do it on your own. I will start from dipole in a non-uniform or uniform field. So we'll start from here. I'll end this class here. If you have any doubts, you can ask me. Bye bye.